Alright everybody, welcome. This video is gonna be about the last assignment, like I said in the previous video on Tuesday. I'm gonna go through it right now and we'll start with the requirements. So, for this one, there was two parts. One to just get acceptable grade, and another part for well acceptable grade. So, of course, I went with the with both parts actually, and yeah, I'll start with reading the first one. So, choose a publicly available CSV dataset and provide a link to the data file. So, I've chosen maybe I should start with explaining what the assignment is about. As you can see here, the goal is to analyze a dataset and create a simple interactable web application to display the results. And this part, the interactable web application, it's for the well accepted grade. So yeah, I chose a dataset about car sales information, where you can see some kind of different car manufacturers and some car models, and what mileage they had and what price they sold for, what engine size, what the fuel type, etc. And then use pandas to load the dataset into a data frame. Perform at least 3 data analysis tasks using pandas methods. For example, calculate the mean or median of a numeric column, filter the data to find specific rows, for example all movies released after 2020, and then group the data and perform an aggregation. For example, find the average sales per a region. And then just save the results of your analysis to a new CSV file. So yeah, that was the first part. And for the second part, the requirements are to create a web application using Streamlit. By the way, I've gotten a new microphone from the last videos, so I hope it sounds a lot better. Please comment if you think it's better or worse, then maybe I'll switch back. But yeah, the second requirement, the app should display the raw data from your CSV file in a table, and add a sidebar with widgets such as a slider, a select box, buttons, and etc. that allows the user to interactively filter the data. For example, if you're using a movie dataset, the user should be able to filter by a range of years or a specific genre. And the last one, display one or more plots. For example, a bar chart, a line chart, or a line chart, using a plotting library like Matplotlib or Altair, based on the filtered data. The plot should update in real time as the user interacts with the widgets. Alright, that was the requirements. Now let's check out the code. So, what have I imported? Well, I've imported pandas, obviously, as it was required here, and Streamlit, we should use Streamlit to create the web application. And lastly, Plotly for the external packages. Plotly is to make plots, similar to Matplotlib and Altair. Then I just imported OS and the date from the datetime module, which is built-in packages. That's why I've spaced them out and put them down here. I think it's a lot nicer to structure it this way. But yeah, this is the first assignment that we have to use external packages for, so it's really fun. It makes it a lot more like real, I guess. But anyways, I'll start by going down to the main function, or well, I guess I can show here at the bottom. I say if name equals main, then run main, and here I have a link to the dataset. So yeah. Alright, in the beginning, here I just set a title for the Streamlit web application, where I put this as the title, and a car emoji for the icon of the page. Then I changed the layout to be wide, because for you guys that haven't worked with Streamlit before, it defaults to only putting the information like in the middle of the page, and I want it wide so it goes to the whole page, basically. That's what this line does. And then I put the initial sidebar state to expanded, since we needed to have a sidebar with widgets, and I put it to expanded as default, so you can see it when you jump on the page right away. Then I put a title in the web application. This is basically a H1 for you guys that have done worked with HTML. Then here I start, this is where the pandas stuff comes in. I start by checking the Streamlit session state and try to get the df key and get its value. But as you can see, in the beginning we haven't stored anything here, so it's gonna default to getting none. And then I check here, if df is none, then I call this function, which I've written myself, and store the return in the df variable. So let's start by checking the getDataset function. What this does is it checks if the CSV file, the dataset, is in the current directory, and if it is, then I just read it in using pandas and store it in the df variable and return it. And if it's not, then I import Kaggle Hub and download it. Here's the creator and the name of it. So I download it, get the path to where it's downloaded. I use OS to join the path with the dataset name, and then I stored that one in the session state, as I've written here. Save it to display it later. So I want, if someone doesn't have it and downloads it, then it should display at the bottom of the page where it was downloaded, if the user wants to know. And then I use pandas to read in the dataset from that path and store it in DF and returns it. So yeah, that's the get dataset function. So after this function, I get the pure pandas data frame with my whole dataset in it. So then I start by dropping duplicates. I reformat the engine size column using the map method. This basically just rounds it to 1 decimal and adds an L to the end. So instead of saying like 1.1, it says 1.1 L for liters for the engine size, basically. And then I store the data frame in the session state. So because Streamlit, every time you interact with a slider or a button, Streamlit reruns the whole Python file. So then when it comes to this line again, then it can find the data frame in session state. So then it defaults to getting that one instead of getting none. So it skips this whole part. Okay. Then I try to do the same thing but with filtered data frame, and of course the first time there's nothing. There's no filtered data frame in session state. So I default to getting the base, the raw data frame. Then I get the minimum price and maximum price of the whole data frame by passing in the price column and adding the min and max methods. Same goes for mileage and year. And these variables I use down here. Inside the sidebar I make a slider where you can choose the price range, for example, and I put the minimum value as the minimum of the whole data frame, as well as the max price is the maximum of the whole data frame. And the default values, this is only the initial defaults or the initial value assignments. So I just put it as the minimum and maximum, and then when you change it, the value is gonna stay like the changed value, basically. Then here I make a key, I pass in a key. This basically makes it remember its previous values that the user selected, so that it doesn't reset to the default values. The same goes for the mileage range and the year range, same thing. And here I first off access the manufacturer column of the data frame and get all the unique values. So what does this do? It goes through the manufacturer column and checks, because I have some different car manufacturers like BMW, Volkswagen, Porsche, etc. I have like 2000 Porsche and like 5000 BMWs. So what this unique method does is it gets one value for every unique manufacturer in this case. So I get a list of BMW, Porsche, Volkswagen, Toyota, etc. And I create a multi-select box using Streamlit and pass in these manufacturers as options, so that the user can select if they only want to see BMW, for example. Here I do the same for the fuel type, so the user can filter for only diesel cars or only hybrid, etc. Then I just pass in a divider and add a download button, like the requirement said. So it's just a button that, if pressed, saves the filter data frame to this file. That's it for the sidebar. Then here, where I actually filter the data frame, I first check if the selected manufacturers, which is this one, if not this one, basically if it's empty, if the user has selected no options, no manufacturers, then I just default to applying every manufacturer, so it doesn't appear empty, the data frame. Same goes for the fuel one. Then here I get the minimum price value and the max price value. This is basically on the sliders where you can filter for price. I have one slider and I have two dots, so I want to get the minimum dot and the maximum dot. Maybe if the user put this one here and this one here, I want to get the value of both of them. And how to get that? Well, I check it in the session state and get the price range, which is stored thanks to this key I passed in. But if it wouldn't be able to find it for some reason, then I just default to the minimum price and maximum price, just to be sure. Same goes for the mileage and year. Then down here, this is where I create the filter data frame variable for the first time. And here I just check, I filter the original data frame, where I check the manufacturer column and sees if any of those entries is in the selected manufacturers, which is the list of all the selected manufacturers. Then I do the same, but I check inside the filter data frame, which I've created up here previously, and I just check their fuel types if it's in the selected fuel types. Then I get all the values of the price column that's between the minimum price value and the maximum price value. So if the user put the slider like this, then I don't want the things on the outside. Same goes for mileage, same goes for year of manufacture, which is the column name of the year. Then, when I'm done filtering, I store the filter data frame in the session state, so that I can find it the next time Streamlit reruns this. I can find it in the session state instead of defaulting to the original data frame. Okay, so now more or less the main filtering is done. So now we have the displaying part. First off, I start by creating 3 tabs. One for a basic overview, one for all the charts, and one for more detailed analysis. So in the first tab, I display the first 15 rows of the filtered data frame, and I put it inside a Streamlit container just to give it a border, a outline. And yeah, I call the Streamlit table function and pass in the filter data frame .head 15 to only give it the first 15 rows, and I put the header above. Then in tab 2 I show all the charts. So I start with giving by doing a line chart, which I give this title to it. Then I check if the filter data frame is empty, if the user has filtered it too much, that there's no rows that match the filtering. Then I just display an empty empty Plotly line chart with just the title. Else, if it isn't empty, then I calculate the average car price per year of manufacture. And the way I do this is by grouping the filter data frame by the year of manufacture, and then on that pandas group object, I check the price column, gets the mean, and turns it into a integer type. And then here I make the line chart. So this is done with Plotly, as I mentioned up here. And first off, I pass in the whole data frame that I want the information on, and then for the X I pass in the index, and the Y I pass in the values. This is maybe a bit unclear. You guys are gonna see it better when I display the website later. And the title is this title up here. And then labels, instead of it saying Y, I replace it with price, since this line, price per year dot values, is the price and the index is the year. Alright, then I do the same thing but with a bar chart. I see if it's empty, and then just make an empty plot with the title. If it's not empty, then I calculate the average car price per manufacturer. So this is a bit different from the previous one. Here I start by grouping by the manufacturer instead of the year, and I access the price column, gets the mean, and sorts the values by descending order, not ascending. And yeah, here basically the same thing. Plot it like the one before, but I specify that I want a bar chart. Then for the third one I make a scatter plot, and this part is the same. The difference is here, where I calculate the average for the price, mileage and year columns, which is done by grouping. This is kinda a lot, I get it, it's kinda confusing. I start by grouping the filter data frame by manufacturer and model, and then I perform an aggregation where I get the mean of the price, I get the mean of mileage and the mean of the year. And then with this new data frame, I pass it into the Plotly scatter function, where I specify the color is the different manufacturer and the size is the year. So this basically makes it, the newer it is, the bigger the dot is gonna be, because a scatter plot has just a lot of dots everywhere, and the bigger the dot, the newer the car, and the different colors on the dots means it's from different manufacturers. Then the x-axis is the price and the y-axis is the mileage. And here I just give some extra data if you hover on one of the dots, and a title. Okay, the last chart is a pie chart, which I display the distribution of fuel types. So I start by not grouping this time, but I'm just accessing the fuel type column of the filter data frame. I get the value counts and reset index. This is kind of confusing. I don't really know exactly what this method does. But then I access the columns and put them as fuel type and count. Then down here I plot it using Plotly again, specifying a pie plot this time, passing in the filter data I got above. And yeah, that's it for this one. Now down here I create a container with a border and make 2 different columns and plot all the 4 charts using Streamlit's Plotly chart function. Then down here in tab 3, this was the detailed analysis section. So I start by just getting the average year of all the cars, the average price of all the cars, and the average mileage of all the cars. Then down here, this is a this is a bunch of confusing code, I know, but here I group the original data frame by manufacturer and perform a aggregation where I make a new column called amount of cars, which is the count of the models. So since it's grouped by manufacturer, I get the counts of all the models that's a part of the different manufacturers. Then I get the petrol count using a lambda function where I check if the type is petrol for every row in the fuel type column, and I just sum them up to get a count, and I do the same for diesel and hybrid. Then down here I check how many cars are tax-free. So in Sweden, if a car is 30 years old or more, you don't need to pay taxes on it anymore. So I thought that one would be a fun addition to add. So this I get by using a lambda function as well, where I get the today's year using the date class from the datetime module, which I imported above. Then I just subtract x for every row, and x is the year it was manufactured. Then I check if that value is more or equal to 30. So this returns a true or false statement, and then I just sum them up to get the count. Alright. Then down here I convert the fuel to percentage, since here I get the petrol count, diesel count, and I don't want the counts, I want the percentages, which I get by accessing the petrol count column and dividing by the amount of cars column, and then just times that by 100 to get the percentage. Then I store it in a variable, and I create the petrol percentage column, which I just round off the petrol percentage variable and make it into a integer. And yeah, as you can see, I do the same for diesel and hybrid. For you guys that are still watching, please comment down below if you mind me taking some breaks, like drinking some water and etc., or if it's just really annoying and you want me to edit them out, because I feel like I don't want to edit and cut as much. But if you guys find it annoying or boring, then I'll start to edit more. Okay, next up, I drop the count columns since I don't need them anymore. Drop is basically to remove. Then I rename some columns, as you've seen up here. I have some underscores in the column names. I realize now that I have it here as well, which I don't really needed, but oh well. I basically access the grouped data frame, call the rename method, specify that I want to rename the columns, and then I specify the name, the old name and the new name for everything. Then I display the above metrics, so the above detailed analysis. And this I do inside a container to get a nice border. I get some columns using streamlit.columns, and I add some metrics to these columns. This is the things I did in the beginning of tab 3. So the average year of all the cars, average price, average mileage. Then I display a table with the grouped data frame, and that's pretty much it for the tab 3. I then, down here, as I said in the get dataset function, which I written myself, if the dataset is downloaded, then it is stored in session state dataset path. So down here I check if something is stored at this location, and if it is, I store it in the path variable and display it in Streamlit. This is called the walrus operator. I reckon a lot of you may not have seen this before. It has a very specific use case. It's not used very often. This is actually the first, as I've written here, the first time I found a good use case for it. So yeah, it checks if this is true. If I get none, then that equals to false, and if I get the dataset path, that equals to true. And if this is true, then I assign the value to this variable, and then I can use it inside the if statement, basically. Yeah, that's it for the program. Now I'll run this to show you guys. Okay, so here you can see the title, car sales analysis and visualization. Here in the overview tab you can see the first 15 rows where I see the different manufacturers, the different models, engine size, fuel type, etc. And here on the sidebar I can filter it. So maybe I only want... Why is this popping up? Oh, this is annoying. Oh well. Maybe I only want to see Porsche. Then, as you can see, only Porsche is displayed. And maybe I want to add the BMW as well. Then I only get Porsche and BMW. And as you can see here, the BMW is really cheap, only 700. I think this is dollars. So maybe I want to filter the price to a minimum of 20,000. And then you can see it is gone. It is replaced with another Porsche. And yeah. Same goes with the fuel types. I can select diesel, then I only get the diesel ones. Mileage, can filter that one as well. And yeah, then if we go over to the chart section, here is the Plotly charts. This is a line chart, bar chart, scatter plot, and a pie chart. These can also be filtered in real time. So if I change the price, you can see this one changed, this or well, basically everything changed. If I just select Volkswagen, then this one only displays Volkswagen, this one as well. You see here the model. This one is the average of all the Passat models. This is the average of all the Golf models, and here is for the Polo. Then I add BMW. I can see now the light blue is BMW and the dark blue is Volkswagen. And here I see the fuel distribution. So as you can see, there's not a lot of hybrids in the Volkswagen and BMW cars. The main part is petrol, and then there's some diesel as well. And here we can see the average price per year of manufacture. So as guessed, the older cars is a lot cheaper than the newer cars. They're up here, a lot more expensive. And here at the bar chart we see the average price for all the cars, all the BMW cars and all the Volkswagen cars. Alright, on to the last tab. Here, as I said before, I show the metrics. I'm sorry for covering some things here, but it just says the diesel car percentage and the hybrid percentage. But yeah, here we can see the average year of all the cars, average price, average mileage. We can see the amount of cars per manufacturer. So we can see that Porsche, for example, has the least amount of cars in this data set, and Ford and Volkswagen has the most. Then we also see the amount of tax-free cars, the amount of cars that are 30 plus years, and we see that Porsche has the least amount since it has the least total amount of cars, so that makes sense. And yeah, Ford and Volkswagen has the most, as expected. This tab does not get filtered. I wanted it to be static and show everything on the raw data frame. And here's a button to download the filtered data, but I'm not gonna do that right now. So yeah, that was it for the final assignment. It's so nice to have this done finally. Now I have some time to relax and focus on my own projects. As I've said before, I've done a Discord bot for my class that sends out a message with the information about the school day's lecture. I'll talk more about it in a different video, and maybe I'll show the code. But other than that, if you watched this far, thank you a lot. I really appreciate it, and I'll see you in the next update video. Bye bye.